go ahead and actually begin this practice exam. And I'll be uploading these videos after the completion of each one so that we build up kind of a mass so that helps you. So we have a 2 kilogram mass lifted 4 meters above the ground. We want to find the change in gravitational energy. Honestly, for the opening of this test, I just want to kind of warm you up. So don't try to do crazy bar graphs and things like that. Keep it simple. Mass, height, and the change in gravitational energy means we go from the ground to the air. So we're going up to a height of 4 from 0. So your change in gravitational energy is simply going to be the m times the g times the h I give you, which is 2 times 10 times 4. So we're simply going to get 80 joules of change. Now, a bouncing ball is launched with 40 joules of kinetic energy. If its mass is 5 kilograms, 0.5 kilograms, how high does it go? Keep it simple. So we have here, maybe you want to do a bar graph. I'll simply set kinetic energy equal to the gravitational energy. So we have 1/2 mv squared equals mgh. As an aside, here we don't know what the m or the v is, but what we can say is since the total is 40 joules, we can simply set 40 equal to mgh, so 0.5 times 10 times the height. So the height ends up being 8 meters when we solve. Yes, because it's 40 divided by 5, which is 8 meters. Lastly, a spring stretches from 0 to 0.2. A second identical spring stretches from 0 to 0.4, and we want the energy of each of the spring's energies. So, energy of spring 1, or spring A, is going to be 1/2 times k times 0.2 squared. And energy of spring B is going to be 1/2 times k times 0.4 squared. And what we can do for the ratio is just take the B to A ratio, which is going to be 0.2 times 0.2, that's 0.04, so that's 0.0. Be careful. We want B to A, so that's going to be here 0.08, because 0.4 ends up being 0.16, 0.08k divided by 0.02 when we're done squaring it. The k's cancel, and so we end up getting a ratio of 4 to 1, or just plain, you can write 4 to 1. I'd like you to simplify 0.08 to 0.02, so I'm not looking for that one. All right, and then for number 4, we have a 2 kilogram box. It's launched, it goes up this hill. Notice I have a little clue here. I say that HA equals 0, VA equals 0, so that's your clue that kinetic and gravity are 0. Since we have a spring, we know we have all elastic energy to start with. And what happens at the end? We have no friction, so there's no dissipated. The spring is sprung, so there's no elastic. So we end up getting a mix of gravitational and kinetic. So when we solve here, our equation is E elastic is EK plus EG. And so we'll start off with 1/2 kx squared equals 1/2 mv squared plus mgh. Gosh, what are we even looking for? The speed. So 1/2 times k, which is 1,000, times 0.6 quantity squared is 1/2. The mass is 2 plus 2 times g, which is 10, times h, which is 5 meters. And it's v squared that we're solving for, so it's 1/2 mv squared. So continuing with this, the 2's cancel. This is plus 100 v squared equals, this will be 0.36 times 1,000, which will be 360 divided by 2, which is 180. So v squared ends up being 80, and v itself ends up being a little under 9. Let me just double check that. I think something like, sorry about that. So the square root of 80, which ends up being, like I said, a little under 9, 8.94 meters per second. So that's page 1. I'll go ahead and actually upload that now.